So this is our first question related to specific heat capacity, etc. Here, the basic idea is that heat which is required by mass m, okay, to raise its temperature by, let's say, delta T. Delta T could be 1 degrees, 2 degrees, 3 degrees Celsius or Kelvin. Depends upon mass, delta T, and also its specific heat capacity. Okay, and this specific heat capacity depends upon what kind of material the body is made of. Okay, so we are just going to use this formula several times in this chapter and then apply energy conservation to solve the problem. So that's the framework, right? So we have to look for this and also apply energy conservation to solve the problem. Okay, so let's start with our question number 1, which says a body of mass 0.15 kilogram has a temperature increased by 5 degrees Celsius when 385 joules of energy is provided to it. Calculate the body's specific heat capacity. Okay, so it is asking us to calculate C. So clearly the C will be simply Q divided by M delta T. If we have all these three values, we will be able to calculate this pretty easily. Now, let's look at what all things are given. So the M is given to be 0.150 kilogram. Note, we have to always put the M in kilogram, right? And then delta T is 5 degrees Celsius. Now, note that whether the change in temperature is in degrees Celsius or Kelvin, it means the same thing, right? The change could be the same number, 5. Okay, because the Kelvin temperature is simply 273 plus the Celsius temperature, right? So when you take a difference, basically you end up with the same kind of difference number. Okay, so whether the value is given in Kelvin or Celsius, we can simply use this as a 5 Kelvin as well. Okay, to put it here. Now the energy provided is 385 joules. So the Q provided is 385 joules. So we have all the three. So we are simply going to plug it over here. It's going to be 385 joules. Okay, 0.15 into 5, right? So that's going to be kilogram and then Kelvin. Okay, so when you do the math, it is going to turn out to be 530 joules per kilogram per Kelvin, and that is what is going to be our answer for this. The specific heat capacity of the mass in question is 513 joules per kilogram per Kelvin, which means if we want to increase the temperature of this body, right, which is of 1 kilogram by 1 degrees, we need to provide an energy of 513 joules. Okay, so now let's switch to part B. The part B says another body of mass 0.15 kilogram has a temperature increased by 5 Kelvin. So earlier, you see, it was degrees Celsius, now it is Kelvin. When the same amount of energy, 385 joules, is provided, calculate the body specific heat capacity, right? So everything remains same, right? So Q remains same, M remains same, and delta T is now 5 Kelvin instead of 5 degrees Celsius. Okay, and as I mentioned, right, whatever the temperature is, the difference in Kelvin and Celsius are the same. Okay, so the absolute value could be different, right? Because when we're dealing with temperature from Kelvin, so plus 273 will be our Kelvin temperature 1. Okay, and then let's say C2 is 273 Kelvin temperature 2. The difference when you do this, basically you end up with temperature TK2 minus TK1, which is in Kelvin, will be TC2 minus TC1, and this minus will become 0, right? Which means the delta T in Kelvin is always equal to delta T in centigrade, and that's what we are going to use, which means the numbers will remain same. Hence our answer will be also same, and that will be 1530 joule per kilogram per Kelvin, right? So we earlier automatically converted a degree Celsius difference to the Kelvin, right? So we got the answer in which ways.